My second example of a background thread work is very similar in its organizational structure to the first one, except now I have a distinct data object named prime calculator. The idea is to create an object and configure it to specify how many prime numbers to calculate at once as a single set, and then do the computation beginning at the specific value. And the trick here is that the object supports calculation of large, of type long, 64-bit integers. So we could try to compute a set of prime numbers above 1 billion, 1 trillion, or 1 quadrillion. In fact, right now, what I have configured this for is 10 raised to the 16th power, which is 10 quadrillion. So let's try running this sample, and you'll see what it prints. And you see we're printing blocks of 10 prime numbers, which are all above 10 quadrillion, which is 1 with 16 zeros. So if I drop the initial value to a lower floor, like 10 raised to the 14th power, which is 1 with 15 zeros, which is 1 quadrillion, and we can try running this example. You can see that now we managed to actually compute as many as 8, and this will vary every time we run it. Maybe sometimes we can get 8 or 7 or 9. It could be a different number depending how fast your CPU is and how busy your computer is. Alright, so our main thread of execution is starting, of course, in the main method, and the parameters that we use in the sample is that, again, I have this keep running variable indicating whether I would like the background thread to continue to run. I create this prime number calculator data object as one of my data attributes. I specify that the number of primes in each calculation attempt, I want to generate 10, and that's what is being displayed in every row that this demo prints on the screen. And this is the first prime number to be generated above this value. This timeout in milliseconds is for the main thread of execution, because what I do here, I just wait for 3 seconds to let the background thread to run and keep computing these prime numbers. And so that's why I have this cycle countdown of 3, and the timeout that I'm using here is I put the main thread to sleep for just 1 second in every loop iteration. So once this wait period is over, keep running is set to false, and we print that the main thread terminates. So the first line here is to start the background thread. So again, this continues to be the demo method, which is just a method outside of the main method. But this is the object method because we create an instance of our main application class and call this demo method on it immediately. So inside the demo method, the same setup as we had in our previous example. In fact, I specify to the data object that I'd like to compute the numbers above this specific floor value. Then we create this working thread. Again, this can probably be simplified to something that looks like this. In this example, again, I start with anonymous class implementing the runnable interface, and in the run method for this background thread we simply call a method named work loop. So inside the work loop we run endless loop as long as keep running flag is set to true, and we use our calculator object to compute next set of 10 prime numbers, because right now this is just hard-coded to use the set of 10, and once the calculation round is complete we print the line on computer screen with these primes. So this loop basically represents our background task running continuously. And you can see that we're not waiting, we're not sleeping for any period of time, just to support a little bit more cooperation and be friendlier to the thread scheduler software. I call yield after each heavy round of computation of these prime numbers. So the demo method is for the main thread, and the work loop method is for the background thread. And of course, this gets invoked as soon as the main thread calls work thread start. I plan on using both of these samples, printing timestamps and calculating prime numbers, when we discuss multi-threading with JavaFX, where all heavy computation like these prime numbers or other data processing tasks like database work should be done in the background. Otherwise, the user interface, the graphical user interface, could become unresponsive and very difficult to use in general.